WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Good day, learners. You are welcome to Eko Learners Support for WAEC and NECO candidates. I'll be your physics teacher for today, and I'll be taking you on the topic alternating current. Let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Alternating current. At the end of today's lesson, the objectives you are expected to be able to achieve are: explain resonating frequency or resonance frequency. You are expected to be able to define impedance, explain series arrangement of resistor and inductor. You are also expected to be able to explain series arrangement of resistor and inductor, as well as series arrangement of resistor, inductor, and a capacitor. Resonance frequency. Resonance frequency is the frequency in which an inductive reactance is equal to capacitive reactance. I'll repeat that again. A resonance frequency is the frequency in which an inductive reactance is equal to capacitive reactance. At resonance frequency, you have your maximum current. Based on the definition, which I call the theory behind it, look at the diagram. Inductive reactance is equal to capacitive reactance. Let's go. X suffix inductive equals to capacitive reactance. But our inductive reactance is angular velocity, while capacitive reactance is 1 over, since angular velocity is 2 pi f, so we have 2 pi f L equals to 1 over 2 pi f c. Because we want to determine the resonating or resonance frequency. So we make F the subject of the formula. X naught, X naught. So we have our X naught square equals to cross multiply over 4 pi square LC. Now we have F will now be equals to square root of 1 over 4 pi square LC. Square root of 1 is 1. Square root of 4 is 2. Square root of pi square is pi. And we have root LC. So if you are asked to determine the resonance frequency, This is the formula. You can see it. Based on the theory. That is why I tell you, the moment you are theoretically sound, analytically you cannot be deformed. The theory says a resonant frequency is a frequency in which capacitive reactance is equal to inductive reactance. And with this, we have come to have the formula. Impedance. Impedance. Just like we have resistance in DC, we have reactance and impedance in AC. A resistance is an opposition. Similarly, reactance is an opposition. Now, one opposition is a reactance. We have reactance of a capacitor and we have reactance of an inductor. However, when we talked about two or more oppositions joined together, it forms impedance. I'll repeat that again. When you have two or more oppositions joined together, it is referred to as impedance. Just like what we have sequence and series. The moment you introduce sign, then it turns to series in mathematics. The same way is applicable in physics. When you have two or more oppositions, then you have impedance. And that is why impedance is defined as the overall opposition of a mixed circuit containing a resistor, an inductor, and or a capacitor. You can see the conjunction, and or a capacitor. And it is denoted with Z and measured in ohms. We have impedance in an RC circuit. Impedance, what does R signify? R signifies a resistor and C signifies a capacitor. Let's look at it how the diagram will be. The circuit diagram. You can see from what we have on the board. The symbol for AC, we have the voltage and we have the frequency. Sinusoidal, can see waveform. Then we have the resistor. We have capacitor. Reactant, two opposition forms impedance. And that is why we have the impedance equals to, we have Z square equals to R square plus reactance of a capacitor. So that Z square root Z square, R square plus X of C square. Where that is the impedance involving two oppositions, a resistor and a capacitor. Now, the tan phi, which is the angle, equals to X, that is in capacitive reactance over resistance. So you can see that. Now we talked about impedance in an RL circuit. That is a resistor and an inductor, because I told us impedance when you have two or more oppositions in circuit. Now we have the diagram similarly. you can see we have impedance in which you have the resistance of the resistor and you're having an inductor there. Two opposition forms impedance. And what do you have there? The moment you see this symbol, you must be able to interpret what does each, because once you see this in examination, you can deduce what the questionnaire wants from you. And from here, once it is, see, you can see what we have it here. Impedance square equals to resistance plus inductive reactance. Then we have, you remove the, and you introduce square root, and you have, then you have the tan phi equals to inductive reactance over resistance. Look at this. Impedance in RLC. It's either it's called RLC or RCL, depending on which way the questionnaire wants it, because he who pays the piper costs for the tune. Now look at it. I told you. Look, we have the resistor, the inductor, and the capacitor. And that is what we have here. Let's look at this example. A circuit consists of a resistor, 500 ohms, and a capacitor of 5 microfarad connected in series. If an alternating voltage of 10 volt and frequency 50 Hz is applied across the series circuit, calculate A, the reactance of the capacitor, B, the impedance, C, the current flowing in the circuit, D, the voltage across the capacitor. For you to understand this, you must be able to see, is this an impedance or a reactance? I told you, impedance is made of minimum of 2. So what are we given? The data. We have 500 ohms. We're also given capacitance 5 microfarad. We're also given voltage 10 volts. So we are asked to calculate reactance of the capacitor. That is similarly impedance. Similarly current and voltage across capacitor, V subscript C equals to unknown. Let's start. Look at the reactance of a capacitor from the formula 1 over 2 pi Fc. That is 1 over 2 times pi times, what is our frequency? Oh, frequency 50 Hz times 5 times 10 raised to the power minus 6. So x of 3 equals to, let's check, let's work 2 times pi times 5 exponential minus 6. Then we have the answer is 636.62 ohms, because reactance is measured in ohms according to the definition, don't forget. Then we move on to the impedance, B. The impedance. What's impedance? That is plus. So we have, what is our 500 plus x 636.62. So the final answer now let's 636.62 plus then so impedance is 638.58 ohms. 638.58 ohms. So we've done justice. We are left with current flowing. Current flowing. We want to look at the current flowing in the circuit because it is involving impedance. Recall Ohm's law, Ohm's equation, V equals IR. But because we are dealing with impedance, we substitute our resistance with impedance. So V equals to I impedance. So current will be V over, and that is current. Our voltage given is 10. 10 divided by 638.58. So and current is 0.16 ampere. So we've done justice to this. And the last one, voltage across the capacitor. It's talking about the capacitor, not the entire thing. So it's going to be V subscript C equals to I subscript C. Voltage across capacitor. So voltage across capacitor, the current is 0.16 multiplied by capacitive reactance in which we have obtained the other time, which is 636.62. 636.62. I hope you are following. So, voltage across the capacitor will give us $101.8. Oh, sorry. What is our current? Sorry. there is supposed to be 0, 1. So there is a mistake there that we have to 0.016 times 636.62. Very good. So it's 10.18. I need 10.18 V. So this is the voltage across capacitor. Voltage across capacitor. I believe you have understood this. Now we're going to have our practice question, which I will give you a minute to do, and I'll be right back. Thank you. Let's look at it together. A series circuit consists of a resistor 600 ohms, and an inductor 5 Henry, an AC voltage of 15 volts, RMS, and a frequency is applied across the series circuit. Calculate the impedance. B, the current flowing through the circuit, and C, the voltage across the inductor. Okay. What do we need to do? Now look at it. The first thing you need to do, how many? We have the resistor and we also have an inductor. So we take given data. We have resistor 600 ohms. We also have an inductor 5 Henry. We also have the voltage 15, and we have frequency 50. What is an impedance? We go for the first thing. For us to calculate the impedance, we must calculate the inductive reactance, because we are not given the inductive reactance. So solution equals to 2 pi FL, 2 times pi times, what's our frequency? 50 times 5. So we have our inductive. Let's go to do that. So our inductive reactance is 1570 ohms, 70.80 ohms. 1570.80 ohms. Now we cannot calculate, because without it you cannot get the impedance, because theoretically the impedance is given as R squared, square root of R squared, plus inductive reactance. So formula, impedance r squared plus x suffix l squared. So that is, what is our r? 1570.87 ohms. We have done the impedance. Now it remains the current through the circuit. Current through the circuit, we can as well make use of this. V equals IR, but this time around is going to be V equals to IZ. So our current will be V over Z. And what is our V? We have been given V to be 15 over 1570.87. That is now do justice to that. Our current will give us 0.0095 ampere RMS. Then the last one, the voltage across the inductor. The voltage is across the inductor. So it's going to be V subscript C L, V subscript L, I, X subscript L. So what is our current? 0.0095 times V subscript L. And that is what we got the other time, which is 1570.80. So we're going to do this 14.92 volt. 14.92 volt. That is the voltage across the inductor. Voltage across the inductor. I believe you have understood this. Compare with what you have, and for any comment or question, get across to us through any of our social handler that will be displayed on the screen. Until I come your way again, have your fun.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.